Well, good afternoon, everyone, and welcome to our webinar this afternoon in continuation of our Creo series, where we're going to take a look at the generative design capabilities within Creo 8. My name is Rob Romanowski. I'm the Director of Sales Operations with 3HTI. And on our panel to assist and ask questions today are industry veteran Bill Stickney, and also we have our Marketing Director, Jeff Gavio. And leading us today through the presentation will be application engineer from PTC, Mr. Paul Dye. So I want to thank everybody for being on. Keep your hands and feet inside the ride as we move. And if you have any questions, be sure to type those into the chat box or the question box. We will try to answer them as we go, but we will definitely answer them at the end. And Paul, what kind of time frame are we looking at today?
We have a pretty short time frame. I'd say we should be able to be done within about 15 minutes or so.
Perfect. All right, I'm going to stop sharing, and then this way you can take control.
All right, awesome. And so let me know whenever you can see my screen.
There we go. What's new in Creo 8? I see it.
And this is, again, part of our series that we've been running with all these different new enhancements with Creo 8. We've gone over a lot of different things so far, from model-based definition, additive manufacturing, flow analysis, tons of new capabilities with Creo 8, everything that we're really looking to move forward with. And what we are going to focus on today is around generative design. So again, thank you for Rob at 3HTI for having me on today. This is an awesome technology that we've really built out within Creo. And again, we have Bill Stickney on the line too. I invite him to share in any knowledge, any insight that he has, or anything that might add to what we're going to go over today as well. But what I'd like to do, I guess, initially is just for anyone that maybe hasn't worked around generative design before, or maybe just is looking at a base introduction of what it is. So in general, what I'd say generative topology in the context of Creo is where we're taking all the different goals and requirements that we might have for a specific use case, right? Say we're building out a part and we have certain stress values that we need to stay within, or certain displacements, or certain parts that we have to build around, certain areas that we need to keep preserved in our designs, but we maybe don't know exactly how we're going to build out the design, or maybe we have a design from last year that, again, maybe just works, right? But maybe is it the most optimized design? Is it the most efficient in terms of all these different values that we're concerned with? Well, this is something that generative takes into consideration, along with other considerations like manufacturing constraints, right? Like, how are we going to build out these designs? What type of manufacturing processes are we actually use to design this? And it's taking all these different things into consideration, and it's going to generate designs that you or I probably would never have thought of. And we're able to use this now as a base for a product that we can start to further refine upon, or even just as a means of concept generation for other designs going forward. And within the context of Creo, you can run as many of these as you want, right? You don't want to use this just to find a design that simply just works, right? That's completely against the idea of what we're doing here. We're really looking to build out those designs with all these different goals and manufacturing constraints in mind, and get to the most optimized design possible, really, throughout the use of this engine. And within Creo, it's broken up into two main segments. So you have first the generative topology optimization tool, or GTO. This is all done within Creo. It's all done on your computer, and you can run as many of these different simulations as you want. And the other side of it here is with the generative design extension, or GDX for short. So this is, again, where we're going to take all the functionality that we have in GTO, and now we're going to utilize the cloud to enhance our abilities and really take that generative design to the next level. So what we recommend is anyone that's looking to get started into generative design, or anyone that's looking to start running these, the GTO is a perfect starting place. And then if you see you're starting to work with lots of other materials or many different manufacturing processes that you don't want to run one by one, you could actually run these more as a batch study, where you could run 20 or 30 different studies simultaneously and do that all in the cloud, right? So that's really the second step, I'd say, with this. But two really strong capabilities that we now are going to be fully supporting going forward in Creo. And to move on to really what we look at in the context of Creo 8 and some of the main enhancements that we made with this most recent release. First thing is around automatic creation of our generative parts envelope. So before, whenever we introduced generative initially, we would first specify what geometry that I want to preserve, as well as the geometry I want to avoid. And then I would lay out an envelope to essentially say, this is the area that we're able to design within. And what we've done now is actually remove that restriction to specify that starting envelope. So the system will, if you like to, automatically calculate that starting envelope for you based on the geometry that you say you want to keep or you say when you want to get rid of. And you still do have the ability to manually define specific starting geometry. You can still do that, but really you don't need to if you don't want to. You can actually just let Creo do that work for you. So it's allowing you to get right into the study that much faster. And we also now made the generative design optimization asynchronous, which basically means that now I can start an optimization, and while it's running, I could be working elsewhere within Creo, and it's simply just working behind the scenes for me, which first helps to speed up the system, helps to free up what we're doing, and we can get more done at the same time while these are being run. From here, we also expanded our draft handling. One of the manufacturing optimizations that you can perform with generative is a casting with a parting line or a split line. So that's going to need a draft angle. And now with Creo 8, one of the things that we're able to do is reconstruct that straight to CAD geometry. And that is one of the biggest differentiators with what we do within generative in Creo, is unlike a lot of other tools where you're able to get that idealization and maybe get the tessellated geometry from your standard topology optimization. With Creo and with the generative engine, we're actually able to construct that straight to manufacturable surfaces that we can mill, we can cast, we can 3D print if we'd like to. Any different way that you're looking to manufacture that, you're going to be able to do that here with Creo. And that's one of the things that we continually build out and enhance, is the ability to get that full reconstruction straight to those manufacturable surfaces. And finally, at the bottom, we also introduced a new manufacturing constraint for minimum crease radius. So anywhere that you have blending as a result of the optimization that you're running between the optimized geometry and the preserved geometry, it'll define what's the minimum radius for that blending, which helps to more, just in general, evenly distribute stress throughout the model, help to create a smoother resulting shape in that optimized geometry. So some of these new areas that I've touched on here, we're going to go over in the demonstration, so I can actually show you a little bit about what this looks like. And then I guess before we go ahead and move on to the demonstration, I wanted to take a moment for Bill, if you have anything that you'd like to add on here, anything that you can provide any insight around just what I've covered so far.
Well, I think the main thing I would emphasize is the ability to get manufacturable surfaces out of the optimized model. The older technology, you basically start with a fine mesh and you remove or add elements. So you wind up with a surface that's like sandpaper and can't really be manufactured directly. So that requires subsequent operations to get something practical. But generative design gives you something you can just work off of and go with it.
Awesome. Yeah, and that does factor in really well with any of your parametric design. So anything you've designed out until this point, right, you can just build this out right in context with that as well. So I think what I'd like to do now is go ahead and show a little bit about what this actually looks like in the context of Creo. So we can go ahead and get started. And in this case, I'm going to be focusing in specifically on the generative topology optimization tool, where we're going to stay all within Creo here. But again, we do have the option, if we'd like to, we could send these out to the cloud and have that run for us as well. And if you're interested in seeing a demonstration of that at any point in the future, feel free to reach out and we can definitely set that up too. But going into our study here, the first thing that I want to show you is just some of the bodies that we have laid out here in the model tree. So this is, again, using some of our multi-body technology that we introduced with Creo 7 to lay out the different areas of the design. First, the preserved geometry that we want to make sure is going to be included in the final design, as well as any excluded areas that we want to make sure do not show up in the study. Any areas that you might have bolts or you have any existing geometry, you might want to exclude that from the study. And the first thing I mentioned earlier is the ability now to get the automatic creation of our starting geometry, or the envelope, based on this preserved geometry. So you can see whenever I select on the bodies that I'd like to preserve, generative automatically builds out the starting envelope for our geometry creation. And this works the same way for any excluded areas. We just select on those bodies here, you can see that the generative envelope automatically updates for that change. So it makes it even faster here, like you can see, to get our generative studies built out in the first place. And I have a few just base constraints and a few different loads, just in general, some physics that we're looking at studying here, wherever we might see any loads based on our use case. But what I want to do now is lay out some of our design criteria or the considerations that we'd like the system to take into account here. So this includes the limit mass, any design constraints. And in this case here, what I'd like to do is use one of our new manufacturing constraints along with some of our symmetry. So here we'll go ahead and define the material that we'd like to lay out for our part. And we can go ahead and jump right into the study. So again, GTO makes setting up these studies very quick, very easy. We can just from there jump right into the optimization. And while that study is being run, we're able to view real time what generative is creating here. We're able to see all the different steps that it took towards getting to our final optimized geometry. So you can visualize that real time. And what we're seeing is a model that's probably much different than how I would have initially thought to build it out, right? It's going to be a lot different than last year's model, but it's going to be even more optimized for mass, for stress, for displacement, all these different things that we care about. And while that study's running, we do have a performance manager down there that we can monitor and reference for each of our runs. And this is here going back to what we mentioned earlier, where you're able to either reconstruct to a tessellated form, like you would see in a traditional topology optimization study, or what we could do in this case is actually reconstruct this to a BREP or a boundary representation. So that's going to be the fully manufacturable curvature continuous geometry that we're able to go through and utilize here. Right, and it just goes through here, reconstructs all that geometry, and it's going to bring it right back into our Creo parametric environment. Right, and that's what we could see. So Creo took everything we had in a preserved geometry, the optimized geometry, and it's built it into a model that we're able to take forward from that point. And we could do analysis, optimization on that. We also have the option at any point here to jump right back into the study if we'd like to. So say your model or maybe some of your design requirements change, you're able to go right back in here, quickly update the study. You don't have to start over from scratch. So in this case, maybe after I've had the chance to review my optimization, I want to refine that geometry a bit. So for that, I'm able to use one of our new design constraints to put that minimum crease radius on, which will again help to smooth out the areas of the design and keep everything at a more consistent curvature overall. Right, so with that new design criteria updated, we just keep everything else the same, and we don't have to go back and redefine everything. We can just jump right back into the optimization here. We can monitor the progress of that study in the process manager, and we can still view that reconstruction real time. And then once the model turns green here, we know our optimization is complete. And what we can see is geometry fairly similar to what we got in the first run, but now that we placed that minimum crease radius on, we smoothed out a few areas, made everything more consistent overall, still kept under our mass limit, and probably made a more structurally sound design. And from here, if I'm pleased with that, we can go ahead and update the design, which means we'll recreate that geometry along with any other features that we've used from that point. And that's really one of the best features of generative topology optimization in Creo is because it's seamlessly integrated with Creo parametric, whatever optimization is done, you don't have to generate a whole new part. You don't have to do data translations like you might have to in other systems. None of that, right? We just simply update the design that we're working with and we can keep moving forward. It's helping us to stay more organized, it's taking less time throughout that process. And ultimately we end up with some really great design ideas that we can move forward with. All right, so that covers everything that I wanted to show today. Again, some really great technology here, some really revolutionary stuff that is, if something that you haven't worked around, definitely something you're gonna want to check out more of. But with that, I can pass it over to you, Rob, or Bill, if any closing statements that you'd like to make, you can do that as well. But that's everything that I have to show on my end.
I think I want to reiterate Bill's point about having a model that is more manufacturable, something with a smoother surface that you're able to use, as opposed to having something with a rough surface. So definitely good points there, Bill. Good points. So I'm going to share my screen. We're going to wrap this up. Just to remind our audience, if you haven't been on one of our webinars before, one of the things that we do for our customers is we want to add value as a reseller for PTC. And in a lot of cases, your company may be modeling something new, may have new hires, whatever it may be. but we offer 1 hour of desk side coaching to our customers for every license of Creo that they have. And the minimum is 2 hours of desk side coaching. So we can remotely work with you to help work through any issues, pick our brain, give you advice. I mean, this is just something that we do for all of our customers. And the ones that have taken advantage of it have been able to overcome some obstacles, overcome some issues, or help some of their people understand how to model more effectively and efficiently with Creo. So feel free to email me if you want to know more about this, or if you want to set up a call with one of our engineering directors. And the way to do that is you can email me directly. My email's there, or info@3hti.com. Another way to contact us is just to reply to the emails that were sent regarding this particular webinar. So once again, I want to thank everybody for being on today. Thank our panel, Bill and Paul, for your time, and for Jeff. And next week, we're actually going to be at it again. Bill is going to do a demonstration next week on the Creo Flow Suite. So looking forward to that, especially with Bill's specific background with computational fluid dynamics and finite element analysis. It's going to be a really good webinar. So thanks again, everybody, and we'll see you next week. Take care.